So here's a question we can answer. We have a solution that is prepared by mixing 5.81 grams acetone with 11.9 grams chloroform at 35 degrees Celsius. This solution then has a vapor pressure of 260 torr. Is the solution ideal? The vapor pressure of pure acetone is 345 and pure chloroform is 293 torr. So to answer this question, we need to find out whether or not the experimental vapor pressure is greater than or less than the calculated vapor pressure. So we'll use the modified Reolt's law equation, taking into account the fact that both the solute and the solvent are volatile. We know that because we are given vapor pressures for both of them, suggesting both of them are volatile. We need to calculate the moles of each of them found in the solution. We are given grams for each of them. Using the molar mass, we can calculate moles for each of them. From these mole values, we can then calculate the mole fraction of each of them, mole fraction acetone and mole fraction chloroform. Hopefully you recognize that the mole fractions, when added together, should add up to 1. Then we can take these mole fraction values with the vapor pressures of the pure substances and calculate an expected total pressure. It turns out that the expected pressure is greater than the experimental pressure. Or, better said, the total experimental pressure is less than the total calculated pressure. So, the solution is not ideal. The only way it would be ideal is if the experimental equaled the calculated. And because the experimental is less than the predicted or the calculated, there is a negative deviation, suggesting there is a negative delta H of solution, and there are strong interactions between these solute and solvent molecules.